So let's move to our next keynote profile. It is my pleasure to welcome Mr. Mrugendra Madalagi, a highly experienced Java architect with over 20 years of expertise application development, cloud modernization, and microservices architecture. Currently serving as a Java architect at JPMC, Dallas, he has led large scale digital transformation across multiple industries. His topic is modern communication system transitioning from legacy networks to cloud native architecture. I now invite Mr. Mrugendra sir.
Hey, hi, good morning, good afternoon, good evening at some places, right? Yeah, it's been pleasure talking and listening to all the conversations from the morning. For me, it was early morning, 4 a.m. And now it is like almost 9 a.m. Okay. So for me, the initial discussions about uh, the AI is how it is we are going to take over and what are the best thoughts we can make it out. Yeah, I like those. And after that, we shifted to technology trends, talking about fraud management, fintech, then supply chain from uh, you can say from e-commerce point of view, right? And then we have now kind of the security. Um, my topic I'm going to share is more from uh, telecom as well as across the domains or across the. Yeah. I hope you can see my screen, right, everyone? Or can you hear me, guys?
Yes, sir. Yes, sir.
Oh, and you can see my screen too.
Yes, sir.
Yeah. So I was thinking about, I mean, people talked about AI. They talked about how their services help us and all that. But for me, it's like I'll be sitting in between when we are transforming their legacy systems from the old monolithic along with their platform architectures to the new platform as a cloud native approach, which can help you to make understanding from AI point of view as well. So that's it. That's my topic from communication systems, from legacy networks to cloud native architectures. So for this, I took an agenda, which is like the overview of the legacy systems, communication networks, drivers for transition to cloud native architecture, which is the second point, and then uh, core components of a cloud native communication systems, and then migration strategies or the best practices, how we can work it out. Because being a legacy systems, which we are sitting from last couple of years, and then you need to get the knowledge out of that, and then how do we strategize so that the industries can be helpful, right? Like that. And then the impacts and the future outlooks for that. Okay. So while going through this modernization or transformations, right? A bit back, we can go, what about the legacy telecom systems we're doing, right? Earlier, we used to be having PSTN networks, and then we switched to 3G, 4G, 5G, right? Like that. So for that, I think you are, uh, is it the PPT getting shared, right? I'm just asking.
Yes, sir.
Okay, okay. Yeah. So just to confirm. Okay. So I was talking about legacy systems and how the telecom domain was working around, right? So we have we have strategies from 3G to 5G, right? Like that. And then 5G to 4G, and then now, sorry, 3G to 4G, 4G to 5G, and then we are going ahead with the 6G. But here, from older point of view, we have networks, we have devices, we have switches, routers, and all that things, right? And when across the globe we have different industries to them we support the telecom supporting from the network point of view, and it is getting evolved in that case. The paradigm is from shifting more or less hardware based things to a software based things. That's where the paradigm is coming out, right? So that's where, from legacy communications point of view, there were delays, there is a time lag, there is a speed issues. We have been that phases, but right now, how is the internets and their speed, which are running from 100 Mbps, 200, 1 gig, right? Like with the 5G speed. So that's where old legacy systems were working, and it evolved back-end technologies as well, right? From applications point of view, we have a small scale of network. The speed was like that, so we are trying to more or less going for applications which were desktop based. Then we move to client server, and then across internet it's like a web application, enterprise applications like that, right? So keeping that in mind, I would highlight on the traditional infrastructure trades what we have. Those were more onto uh, you can say hardware centric, and that's what I talk. Like there are physical switches and circuit paths, and then topologies to be managed, and they were based onto more of from an application point of view. They are more onto monolithic, and they have limited flexibility. If you have to host the server and get it access to certain area, so we have to deploy multiple things. Yeah, that's even for a cost management. Initially companies were invested their own hardwares, their own uh, assets for them, right? And now with the change with the change of telecom, or with the change of 4Gs, 5Gs, right? So the internet being or its bandwidth being a high class, right? That's where we have to change our thought process from building it from monolithic, and that paradigm came like we are trying for API based implementations, right? That's a thought. And I would like to highlight the next one is like common legacy protocols, what they were following, right? There were signaling protocols, there were voice communications, PSTN-based connections, analog digital protocols, right? And then they are still there. I mean, it's not like they are not there, but there is an improvement, right? Right now, we can talk at the same time we can stream over a video, and then that's a combination both the things, right? And then there are routing mechanisms what were implemented, and then there is a data transportations over TDM multiplexes or streams over one channel to another channel. So this was a planned and this was a thought process what we went. Mm, and I think there were legacy systems and their metrics and the challenges. What I would add to is the legacy systems were highly operational cost. They have limited scalability, inflexible architecture, and then they are less. If I mean they need a efficiency, but that was not reachable to the one we are expecting now, right? So there were limitation in terms of difficulty for modern IP services or outdated security management restriction more. I mean, the way we talk, right? Like we have fraud management tools or fraud management applications, be it like a protocol level at network layer. So those all are coming because we have evolved a lot from there. And there were opportunities point of view. We if we have to make a modernize for them the old, so you have to reinvest the cost, right? And that's where we were the companies were hesitant because earlier IT as for any industries, the investment was almost like a kind of from the budget point of view. If you think like earlier, it used to be 50-60%, and then they reduced to 30-40%. But now they are again coming back with the evolve of a technology. They can invest for now modern AI technologies. They can invest thinking of around 50-50%. And I mean, that's how it goes up and down. But at the same time, they are thinking across the corners now, right? Because application should be flexible, it should be accessible, availability, if you grow the users, then it should be resistant, right, and resilient also. There are, along with that, they are thinking earlier we used to have a risks associated with the security vulnerabilities and potential service disruption because the services are down, the application are down, people are not able to access it, and then they used to raise the concerns. So those were the earlier legacy system metrics, but along with that, then we transform from legacy to a cloud native, where what are the transition drivers for them? Right now, we can see around uh, because of uh, connectivity, the network, and I would say transitioning from 4Gs to 5Gs. This has built around 49 billion devices, IoT devices, which we are expecting by 2030. So that much data, that much traffic to be built over the network, and at the same time, that much bandwidth is consumed across the industries, right? So that's a that's what it's been expected. Like it will go around more than that. I would say 29 billion devices, or more than that, can get provisioned for the IoT services. The way I would think the IoT services, the way we drive away, and before driving, we can connect to a home. We can see if the cooktop is ready, and then we can get ready some hot dishes or microwaves. So those all coming right now, and that can lead to multiple uh, traffic, multiple bandwidth consumptions, how we are going to direct over there. So these all are evolving, right? And that's where we did the transitions, right? And from that transitions and from those all technologies improvement, I'm taking a small piece of change from applications, how they are going to evolve and how they are going to changing, and how our microservice based architectures are helping them out. That's a small part I'm going to consume here. Okay, so we as a part of cloud native implementations, what all things are we are keeping in mind? So right, so we have virtualizations, right? We have VMs, we have containers, which are the Dockers, what we can which can be used for creating the images. So that can be a lightweight, and that can build runtimes, right? Instead of bigger containers we used to have earlier, WebSphere, WebLogic, or Tomcat containers, a big container you are deploying on a host. Instead, we will have a Docker management or Kubernetes management. On top of that, we have orchestration associated with this Docker management, right? And then we have also the because as an application path, right? We first we have to think how we are going to putting over the network or over the um, over what do you say, mm, when we are trying to deploy the applications, how it should be, how much memory should be consumed, how much CPU to be utilized, and how frequently we can deploy them, and how we can scale them, right? Keeping all that factors, the virtualization to cloud native went from with these factors, right? And then we will have a cloud native CI/CDs. that is useful for decoupling software from hardware, right? So that dependency we are trying to we try to remove it, right? And we will be going a step ahead for that. These all the things are still working on with their legacy systems. Some of them were mainframes, some of them were built with the old logic, and I came across with different industries. How do we transform it, right? There are different approaches to take it. That's what that I would say, and it has made a cost effective in terms of what I would say is because we spent on hardware from own industries, right? Instead we go for a cloud services. They are based on hourly basis, or they some of the services are like how much you consume, use as you go, right? I mean, the much you use, you will get a more cost. If you use less, then cost is less, right? Like, and be the competitors like from AWS point of view, or like Azure, GCP, and even individual players are coming like IBM planning. Yeah, those all are coming with their cloud native or cloud services based on the cost, right? And that cost is coming around 40% lesser than what we used to have earlier, right? Uh, so this is uh, what I would say is we thought about the older system, how it was behaved, what made them to cover to the next level, and how we are going to do. Now we covered what was there and why we have moved it, and how we are going to do it. So that's nothing but cloud native commutative core, right? That's what I'm going to cover next. Okay. So overall, we talked about AI computing, models, you have MCP servers. Everything has got a built-in knowledge, but from the legacy systems, how we transform that knowledge, right? And how do we utilize it? At the same time, how you feed to the applications, right? So that all is question solved more from a microservice-based architectures and their orchestrations, right? So. mm, uh, Microservices are nothing but small scale services which we used to have earlier web services or soap services, right? Soap services are more closely towards high secure communications over XML and SSL, right? So instead, even microservices have built on along with the same line, but it is more scalable. We can scale the services deployed from one to end range, I would say, right? And they are not tightly coupled because every service independently provide its own unique features, and we can integrate, we can call the services, and that way we can conclude the functionality. And that is where when we are on these host servers, when we are deploying, or on the clouds, when we are deploying these services, we'll get a small snapshot, right? Which was there from monolithic point of view. You have huge applications to be deployed, which takes times for a deployment, and then it takes time for verification, and that way. So instead, we are going for this loosely coupled independent services, uh, and they act as a independent components from entire application points of view, right? Because they are associated with their own data set connections, or you can have your own schemas for associating the functions, be it like from telecom point of view. I mean, I work for integrations on the AT&T sides. uh, then JP Morgan, they have their legacy system from uh, I mean, they can be from credit side or lending point of view or depositing account. So those all had helped to understand how it is growing, right? And to draw a line like how we can grow from their legacy systems to this microservice based approach. There are certain ways. We can think of domain-driven approaches where we try to break it the domains into subdomains, collectively get the information and define a service, right? That's one way. Second way, I would say, like where we are thinking, okay, I need my own legacy systems running as well as I'm looking for some of the services, a part of them to be developed over the microservices. So here we are using cloud native approach as well as we are trying, I mean, we are using kind of a strangler approach where we are trying from uh, part of their applications because those systems are running and the industries are scared or the stakeholders are scared. Okay, I cannot rebuild the entire logic or I cannot do it because this was running from last couple of decades, and what if it goes wrong? It is actually a real time, right? And what if from the capital market point of view or under that risk portfolio, under that we have compliance things, right? And which counts based on single transactions, right? If there is go up and down, then it leads to a big impact to the industry, the client, and then your kind of that's what we were thinking, like, okay, your legacies are there, we will keep part of it and we'll try to break it and small pieces we can get it deployed and then we can consolidate. It is a time taking, I understand. At the same time, how it will help it, those services, how it caters to build your analytics, how it caters to streamline or from stream point of view, how it caters to your LLM models as well. So these all those all thoughts are kept, and that's where uh, mm, the more trend is coming towards microservice based implementations to connect or from the existing data transforming to this streaming based APIs or transforming to the models. So that's a best fit, I would say. So it can be to work it out in that. So uh, we are defining functionally uh, either domain driven or you can say strangler or you can based on different I would say based on suppose you have a uh, services based you can define, and that way you increase the microservices, right? That's all. Then we have something from because the services or the applications are getting derived or created, right, as a single service, you have front ends associated. So front end services get fall in different way, right? Those also we can integrate. At the same time, how we are going from deployment point of view, because this become an individual small nodes, and then we wanted a container for them to be deployed and we wanted orchestrators for them, right? That's how it is growing. And um, then after deploying those services, how you're going to measure its health, right? Because that's an additional part which is coming, like cloud services provide. You have observability, we can health check so that the services are down upfront. We'll get the alerts, we'll get to know, okay, these are the nodes or these are the pods are down, and then we can take care of that one. So this is coming as a part of across cloud native approaches, right? And then I mean sometimes with the automations we can go for a self-healing of those nodes, right? And we can manage the fault tolerance for them, right? That's all about a high level microservices. And then I think I talked, but I didn't move the slide, right? Okay. Mm, from microservice point of view, microservice communications point of view, right? Because you defined uh, your existing systems, you broke it into micro level services, but how do they communicate, right? Because individual services is responsible for giving their own functionality. Uh, you can communicate based on three of these ways, whether you go for a RESTful APIs, like you call one client to another client, if it is a synchronized way, you need a quick data. That way you can use for the RESTful APIs. If your communication or services which are like you can say from one service to another service, another to third, and that way your communication is a big, I mean, mostly we try to avoid it, but there are dependencies, or you may connect the services one after another, right? Once you get the response from one service, you will wait, you will request for another. So that, whereas GCP protocol, right? I mean, I forgot to mention one more here, uh, um, which I would say, mm, uh, it's not GCP because gRPC is, I would say GCP, right? And gRPC is a Google Remote Call Procedures, which is two-way binded sockets, and it can have high performance, which can connect between the services, and it keeps a longer connection. That way, you can have kind of a chat channels, right, where we are connected for a long time. We can exchange the message as and when the message is ready from one place to it will get received to the other place, and but there will not be a delay. So that kind of things are when we are doing a calls, or when we are trying to communicate from one microservice to another, so that and we need to have keep a longer connections. That time we are going for this gRPC protocols, where we can use that. And I think GCP, I forgot to mention. Okay. And we can have a bonding with the legacy systems also, where we can use uh, we can use existing cloud services over the VPNs, or over you can say from the security point of view, you have security groups which can get involved to make the communication with the existing legacy systems also, right? So uh, that's next thing. And yeah, these are all thought process at a high level, how we can build the microservices, what it facilitates, and then how it communicates between services, that, uh, based on the need, right? And then what are the migration strategies, right? Because you have a legacy system which is running long time, and you are trying to think about migrating. As I said, there can be uh, uh, s- uh, I think I said, like, you can go for a lift and shift. We can go for some of the services, break it down, and then deploy individually, or you can go with the strangler way, where I said, like, you can go for half of the services which are at the priority, we can deploy them, or where is the business dependency is less, right? And you have dependent applications which is less, we can move them. Those functionalities we can move it out, right? Yeah, that's how I can make it at the high level. And then uh, we have how do we deploy them, right? And what are the benefits compared to the old legacies, right? So we have the I mean, earlier we used to have containers. I mean, not the containers, like the servers, which keeps on running forever, right? And then we at the weekends or sometime we just get shut down, and then we reinitiate, so that we have clean up the memories. Here we have facility of pods which can be managed. If the pods are getting you can say, like, it's a blue green deployment kind of thing, right? Where we are thinking about we can resting some of the services through uh, um, and then we are spawning of other pods, so that it can be a kind of blue green, right? Yeah. Now I think yeah, from this, how it goes for cloud natives, how we are going from how it is going for safeguarding and governance of the systems, because we have our orchestrator which is sitting to take care of the applications. So at the same time, uh, cloud provides different security feature at the fire level. The way we have firewalls, we have security groups. right? That way, which can safeguard. We have our VPNs, right? And that way, from one set of microservices or one set of functionality, what we are trying to connect to other across the region. So we have to create a channel between them. So Mm, from cloud native point of view, there are services which can help it out and it can safeguard, and that way it can be controlled under that, right? That's how I can make it. So, oh, impacts and outlooks, yeah. So, so from impact and outlook point of view, uh, because the now we have backend services which we transformed, which caters to high end outputs to the front ends, right? So you have got to change with your UX, right? It can be a quick reactive based, uh, React based or Angular based, or you have micro front end based or back end front end based. So different UX platforms are enhancing to cater or to connect to these backend services. At the same time, these backend services doesn't only provide connectivity with the UX, but they are also connected with the streaming services, right? Like being a Kafka streams, or uh, y- you can have Glue, or you can have Kinesis. So those are the streaming platform which can get connect and which can use for analytical purpose, and at the end it can connect for your modeling things, which can be used for building your custom models, right? Based on that one, right? Because every industry doesn't want to include LLMs, but they wanted to customize their own model so that that can be helpful internal to the applications, right? And uh, mm, they can help for to evolve from their old legacy system mistakes to this one. So that's another thought I would say, and I think yeah. So certain uh, trends, what we have thought, uh, we had a standalone architectures point of view. We have edge computing integrations. We have AI-driven network management. Then we have serverless computing. We have network function and virtualizations, and then software-based networking. So this is more trending now towards like when we are moving from 5G to 6G, 6G and onwards. So software-defined networking is that's getting added from cloud communications. And so this is what it can lead to. Earlier, we used to have mm, networking over the devices. Now, all those are covering with the software-based networking, I would say. Yeah, I think that hand to hand go along with I would say telecom or a network point of view and their applications, right, which are deployed across, how they can help it out, right? So that's where we sort of a cloud native approaches which companies are using it and they are transforming their systems. Yeah, that's at the high level. So if you have uh, any questions, because uh, or anything strategies to be planned for any transformations, yeah, we can work and I can answer those questions. Yeah, this was more on a high level. Yeah,
Thank you
thank
so
you
much,
guys.
sir. Thank you
Mm-hmm.
so much for that insightful presentation. If anyone has any question, they can raise their hand.
Yeah,
So, sir, as there are no question at this moment, thank you so much once
mm.
again.
Thank you. Thanks for this. Mhm.